Thank you so much for being here. I'm really excited. Thank you so much for AWE for having me, and let's just get started. So when I was really young, I used to play with a lot of different Legos, and I used to build a lot of different structures out of those Legos. So I used to build anything from towers to Lego mansions. That was kind of my thing. Anything that you could read from the manual, I basically built. And that was basically my childhood, thinking and believing in things and then building them to make them happen. As I started to grow a little older, I actually realized all the different exponential technologies and so many different things that are out there that I could build on and I could foster a future with. And one of those things was actually creating an environment for myself where I could build those moonshots and build those projects. And that's why when I turned the age of 16, I'm currently 17, I decided to join a hospital at the forefront of that research, the Hospital for Sick Children, as a cooperative education student and as a researcher. And a lot of the research that I did there was based around cardiology, artificial intelligence, genomics, all these different types of technologies and areas that I explored. And it was incredible because it was a perfect environment for me to foster my project building, but I transitioned from building things with Legos, building mansions, building, Lego towers, to actually building things that could help people and impact people. And I was only able to find that at that environment at Sick Kids. Patients are a huge part of what I do. And, meeting patients, talking to people, getting a different perspective is something that I believe is one of the most important things in life. Whether you're, older than me, younger than me, doesn't really matter. Everyone can have different unique experiences. And one of the reasons that I really believe that is that I had that. Being at Sick Kids and being in a hospital where you're constantly surrounded by people who, are not in a great physical state and who need someone to help them and who need someone to fix them up, it brings a different type of momentum to what you're doing, and it instills a different type of passion in you. That's why whenever talking to any one of my patients, I always get this sense of drive and this new sense of purpose and perspective to keep on going, even if, I'm having a hard day or even if I want to give up on a project, because they made me realize that I'm doing this for a cause that's greater than myself. I'm living for something that's greater than myself. When I don't like a project or I don't like an outcome, they gave me the strength to kind of move on and reiterate and implement feedback and keep on going, have that growth mindset towards life. Because when you find someone that doesn't have something that you do, you really want to try like hell to give it to them. And that was me with my patients. And most 16-year-olds, 17-year-olds can't say that they have those experiences of talking to people from all walks of life. But I was fortunate enough to be given that experience. And from that, I used that to kind of power a lot of the projects that I was working on in the future. So this is actually a picture of the lab of some of the people that are from the artificial intelligence and genomics section. And these are the people that I love being around, because when you find people who give you constructive feedback and who give you, the perfect mix of support, but also giving you all these different pieces of advice and really helping you and guiding you through life is really important. I'm the youngest person here. As you can see, I'm actually in the picture in the corner, but it's crazy to me how I can be able to build a life with these people and with these researchers and with people who are at the top of the game right now in terms of technology, and learn from them and grow from them. They're really my inspiration. And you have to be in an environment, if you want to be a moonshot thinker, for yourself to be able to foster moonshots. You have to be in a really supportive environment. And that's what Sick Kids gave me. So I am a huge fan of underdeveloped technologies that are going to hit their inflection point in the future. I know that for sure, that so many different emerging technologies are going to hit their inflection point. And one of them is 3D and 4D printing. Don't get me wrong, I love artificial intelligence, machine learning, all these different types of emerging technologies, but 3D and 4D printing is something that is incredible. You literally can print up a live model. And I'm not just talking about the 3D and 4D printing that, you can print up toys with, or, I've seen people putting together drones. I'm talking about the 3D printing that could save a life. Instead of just, if you think about your inkjet printer at home, we put in the ink and it prints words on a piece of paper. For 3D and 4D printing, you literally put in things like biofilament and, living cell filament, even a patient's own stem cells to prevent rejection. What if we could use that as the ink and print up a live model or a live organ that could substitute for that? Organ transplantation is a huge problem in our country, at least where I live in Canada, and we need to be able to, have patients who can rely on different technologies to give them a second chance at life, not just other people. So that's why 3D printing is so powerful, and it's a technology that I'm really passionate about, and I've gotten to explore at Sick Kids as well. When I got into my co-op, I also did a lot of research into cardiology. The human heart is such a fascinating, organ in our body. It literally pumps blood. It's basically our life. It pumps blood throughout the rest of our body, gives our body reason and momentum to keep on living. Without it, every other internal organ and structure will fail. At Sick Kids, I started researching into a specific disease that actually causes a narrowing of the pulmonary veins in the body called pulmonary vein stenosis. And it leads to, the narrowing of the pulmonary veins. By that, blood can't flow through the rest of the body. It can't flow through the heart. And by extension, it can't flow through other organs, and the organs start shutting down. We can't catch this disease at a very early stage because it only shows symptoms later on. But this is just an idea of a lot of the struggles that we've had with the research, me working at Sick Kids and instilling all of this and being able to participate in that is incredible. I've seen live heart tissue being grown in our labs, and just to be able to be there and see that, and as such a young person, be inspired by that is crazy. So we're trying to find different solutions where we could solve that disease in really young kids. And that's where I bring your attention to intersections between technology, something that I'm really passionate about. Intersections between technology are where we're going to completely change the future. That's why I'm super passionate about how we can combine different types of technologies and problems together. We have an emerging technology. There's no point of leveraging it if we can't use it to solve a problem. So in this case, we've been researching into how can we actually 3D print an organ like a human heart or human lung or something to, be able to be put in the body if the organs fail, by extension, pulmonary veins, blood can't flow through the body. What if we could get to a point where we could literally print pulmonary vein tissue, like new pulmonary vein tissue? The possibilities are endless. And that's just something that I've been researching into, working at different companies, starting different research projects with different hospitals, and taking a look at how we can actually leverage that to make a huge change when it comes to cardiology. So this is actually an augmented reality model that I was able to build, and I wrote a lot of articles and videos about it. It's something that I'm really passionate and excited about. The idea is that if we were able to scan a device, let's say a phone, over just a simple textbook, an augmented version of that heart would appear. So as you can see, the heart is a little bit in the background to that textbook. And this is just a basic heart model. So it's nothing special, but this is just something I've been playing around with in terms of modeling it using different softwares, and then being able to program it, build it out, and see how we can turn it into an augmented version. This is just an example of how we can leverage different technologies to make a huge impact for educating patients about their diseases, their heart, in augmented form, and then also educating new students and a whole new generation of doctors. We're seeing this inflection point when it comes to different technologies and how we can leverage that to teach people better. And this is a perfect way to do that. So shifting our attention a little bit to a different area that I've been looking into. When I got to Sick Kids, I love things like cardiology, emerging technology, don't get me wrong. But one of the areas that I'm super passionate about today, that's kind of like my own personal passion project, is global health. And global health is such a huge problem. I was reading a report where WHO released that 45% of member states reported they had less than, like one doctor, less than a couple doctors per 1,000 patients. And that was really, really hard to see, because we're seeing, again, that the rise of emerging technologies in our part of the world, but we can't really deliver that to other countries. And it's just heartbreaking to me to be able to see that. So that's why I really got into global health and figuring out a way that we can give better rise to global health awareness. We can educate people better on global health. We can, treat other people in developing countries that have diseases that don't have the same resources that we do. And also virtual reality is another technology that I've been exploring. Global health is the problem. I've been looking into virtual reality for the solution, which I'll talk about in a little bit. But virtual reality is such a huge part of our world today. It started out by being something that we could transfer online platforms for games for, to make them all virtual. But now it's actually becoming a tool that we can use to possibly save a life and educate a whole new generation of doctors. I'm not just talking about virtual reality that's used for gaming. That gives incredible visualization, but we've taken inspiration from that. And now we can convert that into virtual reality for medical diagnosis, virtual reality for medical training. UCLA School of Medicine said that they were actually using virtual reality training modules, and their students had an increased efficiency of over 230%. That's crazy. And that's not done just by using regular technology. 230% is an incredible outcome. And that's what virtual reality does, is that it takes students into a completely different area and allows them to educate and learn through that. Even patients, so many virtual reality reports have come out by using VR to help other patients through their PTSD and brain disorders by putting them in a different environment. And again, the whole purpose of this talk is to bring your attention to different intersections between technology. I've been exploring them with 3D printing and cardiology, and now global health and virtual reality. I've been researching into different ways that we could literally use virtual medicine and cater that toward the developing world. Possibly at other hospitals, build relationships and partnerships with hospitals and clinics in developing countries and have them learn through the same type of technology that we have, have us deploy that virtual reality technology to them and have doctors and patients from all parts of the world connect. So to solve a lot of the global health issues that we're facing today, we actually have a platform called Telemedicine that has recently been built. And the reason that telemedicine is really powerful is that it's basically, during the pandemic, we obviously can't go to the doctor's office, we can't go to clinics, we can't go to hospitals. So we have this notion of being able to see a doctor virtually in front of us, being able to Skype them, FaceTime them, a lot of different technologies, even Zoom has been incorporated into telemedicine. And it's incredible the impact of telemedicine and what it has. The problem with telemedicine is that we're only seeing it in 2D form. There's a lot of stuff that we can't do. Patients can't come in for physical exams. We can't really see the patient's anatomy that well. So we've been figuring out better ways of clinical diagnosis when it comes to telemedicine. And that's just one of the solutions, temporary solutions that we've been using to help other patients in developing countries get access to more experts and doctors and, get them to have better treatment for their diseases and guide them through a lot of that different stuff. And that's why I've been working on how we can start changing things with the mix of global health and virtual reality to create virtual medicine or virtual hospitals. This is a project that I've been working on for a long time, and it's kind of my vision of the future. How can we literally build partnerships with a clinic in a developing country and have their doctors, our doctors, patients from both parts of the world be able to connect over virtual reality? And how can we give more rise to that technology? How can we, allow doctors and patients to connect from different parts of the world using that type of technology and allowing them to connect virtually is something that I've been working on and something that I'm really passionate about right now. So that's how we can start changing things and allowing doctors to better understand what's going on in the patient's body by seeing them virtually and by seeing their, hearts and what's going on internally. So this is actually a model that I built using the Autodesk software, which is basically a 3D printing software. I was able to model that and turn it into kind of like a virtual hospital, my vision of the future. You can see that there's an MRI machine. There's multiple different things that we can do here. And you can think of this as like characters in a video game, right? Characters in a video game, if you are connecting with your friend through a virtual reality video game, both of you guys would be on the interface. You would be talking, you would be connecting. Using SLAM, you can also detect an object's motion in real time. It translates to the virtual world automatically. For example, if you were to take a step forward, that's what also would be translated into the virtual world. So you can kind of think of it as that, except doctors and patients interacting over a virtual platform. Obviously, we would have to test this out in our part of the world first, but this is something that I've been working on developing. And ultimately, how can we give people in developing countries who have access to clinics access to this type of technology as well? This is kind of a zoomed in shot of what's going on with the MRI model. And we can even, be able to convert possible MRI images to a virtual platform. We've done that with a lot of different portable devices, wearables in terms of telemedicine, but shifting our focus, how can we do that with virtual reality? If a patient were to take an image of, for example, their heart or their brain, how can we transfer that to a virtual reality platform and have other doctors access that? I'm 100% sure that we'll see a lot of more rise with this in terms of 5G technologies and, having better connection and latency for that type of stuff. So this is kind of where I bring your attention back to why we're doing this in the first place, or why this is one of my biggest projects right now with virtual reality in medicine, because we want to give people access to experts through VR medicine. There's nothing more powerful than having a strong network of doctors and patients, being able to connect. There's nothing more powerful than allowing patients to feel that support from some of the most powerful hospitals in the world. I know at Sick Kids, there's so many people that we have partnerships with in clinics in developing countries that we have to fly over there. A lot of our doctors have to fly over there to be able to check on them. Virtual reality can kind of change the game for that and allow people to connect over a virtual reality platform instead. And we can put those resources towards virtual reality equipment. There's nothing more powerful and more incredible than allowing people in those developing countries to feel like they have access to some of the most incredible experts in the world. So I kind of want to end off on talking a little bit about what I've learned being a 17-year-old woman in the industry and what I call my Riya philosophy. So first of all, be the CEO of your own life, take control and boss up. Being part of the Knowledge Society, which is the Human Accelerator program that I'm also part of, along with Sick Kids, it's incredible because I actually run a startup and a company on the side that I'm working on towards solving for the Sustainable Development Goals. But what I realized doing that in my research is that I cannot be a CEO of another company if I can't even be the CEO of my own life. Obviously, to an extent, we have different parts of our lives controlling who we are as people, whether it's our parents or siblings, like whatever it is. We obviously are not fully control of our own life when we're growing up. But one thing I realized is that being able to take that control and understand and being able to own up to my decisions is a huge factor of what makes me different than other people around me. Boss up, take control of your own life, be the CEO. The biggest company that you can run right now is yourself. Think of yourself as a company. What does a CEO do? They come in a room and make decisions. You can do that for yourself too. Are you going to build yourself up with a decision one day, or are you going to break yourself down? Those are decisions that only you can make. And lastly, be a moonshot thinker. See it, believe it, dream it. We need more moonshot thinkers in society. There's no way that we can achieve unconventional success by taking a conventional path. That's why I'm so inspired by the President John F. Kennedy and the moon landing, because no one ever believed in something as powerful as that without it being happening, right? If it didn't happen, we wouldn't believe in things like moonshots now. And that's why it's so important to go back and think, okay, well, if we were able to do this in the history, our future and our past was completely built on moonshots. Our future will be completely built on moonshots. So be a moonshot thinker, see something, believe in it, and then put it to life. And that's what I did with all my projects and what I'm going to continue to do. So at the end of the day, I used to build a lot of different things with Legos and, put a bunch of different pieces together to build towers. But now I'm putting different pieces together and I'm putting different technologies together to be able to make an impact and save life. And that's what's most important to me, is impacting people, inspiring others, and giving more rise to emerging technologies like virtual reality, augmented reality, and 3D 4D printing. So I'm happy to take any questions right now. This is kind of where you can reach me, or where you can find my website and where you can chat with me if you want to say hello. But yeah, super excited. Thank you so much. And I'm ready to take any questions.
Hi, Riya. I love your just enthusiasm, and I think you inspired everybody here. So if that was your goal today, I think you did an amazing job. So we just have time for a quick question, unfortunately, but the one that came from Philip Leveld. Hi, Philip. Can biological 3D printers print complex compound material structures? They can print 3D objects composed on one type of cell now, is that correct? And can they do more than that?
Yeah, so right now I'm just researching into 3D printing. There's so many different questions that I even have about the 3D printing process. Personally, I'm just looking into how we can 3D print hearts using, for example, things like stem cells from patients. So basically the way that 3D printing works is that we're able to, kind of like your inkjet printer, right? You have like the ink there that can print up a model or print up like a piece of paper with words on it. That's the same exact thing as a 3D printer. And the crazy thing about 3D printing is that I think in society, you see these articles about different companies being able to 3D print complex structures. We have to take everything with a grain of salt because we're definitely not as far into the future as 3D printing things like actually moving like biological hearts. But right now, that's our goal. At Sick Kids, we were able to kind of take a look at artificial tissue and actually being able to grow it. But we're trying to take a different approach with how we can 3D print models. Right now, we're not doing any bioprinting because we still have to see how we can get the measurements. So we're just using basic materials like thermoplastic, which is just like a basic 3D printing material, to 3D print the models first to see how we can get them to interact in the body and figure out the science behind it. But yeah, I'm just researching into 3D printing. There's so many different questions that I have as well, but that's like what we're doing at Sick Kids, being able to use 3D printing filament like stem cells to kind of activate that process.
That's great. Well, thank you for answering that. Thank you for really an incredibly insightful and inspiring presentation. We're going to move to our afternoon crew now, but thanks all of you for joining us. And again, Riya, really impressive work, and look forward to hearing you next year and what you've accomplished. Take care, everyone.
Thank you so much. It was great being here.